All right, at the end of the last video, we figured out the multipliers here. We came up with an average multiplier of 1.32. Okay, so we had some equation, f of x equals a times b to the x. This would be our multiplier, wouldn't it? A times 1.32 to the x. Now, how do we figure out a? Well, we can use this first point here, can't we? And if we look at population in millions, because we don't want to have to drag all this around, we can say f of x in millions, right? 3.93 equals a 1.32, and this is going to be t equals 0. We're going to use our timing as decades, the number of decades after 1790. So this is t equals 0. So we put a 0 in, a equals 3.93. So our rough equation would be this, where f of x is in millions, right? Units, millions of people, 1.32 to the x. So this is us finding the rough model. What if we want to use our calculator? Okay, so if this now, we're not going to put years in, this is going to be decades after 1790. So our x here would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should be similar. So I'm going to go and look at my data that I've put in and make sure that's what I got. Stat under edit. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? And let's do a regression. Well, actually, let's look at the scatter plot. Zoom, stat. So I do have data that looks like it could be exponential growth. So now I'm going to take stat, go to the column, down to my exponential regression, which is 10. As long as this is L1 and this is L2, I'm going to come up with, and I'm going to have this in millions, right? I'm not putting that big number. I get something that looks like this. Y equals 4.11, 1.32 to the x. That looks pretty close to what we had on the other page. F of x equals 3.93, right? 1.32 to the x. Now, the difference between these is that when we did it roughly, we only used 1 point. When the calculator did it, they used all these points to try to figure out the right value for a. So this would be our exponential regression for this data, okay? Oops. Now, we are going to have problems where we're going to use these models to predict. So I could say, find the exponential model that fits this data and predict what the population was in, we'll say, 1920. Well, if I go down here, it's 1900, 1910, 1920, that would be when x is 13. So couldn't I simply plug in f at 13 and get, I'll use the regression data from the calculator, and I could calculate the population in millions of people, couldn't I? In millions of people. The other thing I can do is, let's see if we want to see how well our data fits our scatter plot. Well, I'll plug in 4.11 times 1.32 raised to the x, and then it'll overlay on my data. Oops, I think I put the problem in wrong. As soon as I get this, we're going to end here in a second. You will see the homework for this on PowerSchool. You'll see the homework for this on PowerSchool, so give it a go and look at the Word document. Thank you. Bye.